Okay, last question on your quiz said that Mr. Belcastro is debating on buying a phone plan from 2 different phone companies. This is very true. Bell is offering a plan at $20 a month plus 5 cents a minute. That's made up. And Rogers is offering a plan at no monthly fee, 15 cents a minute. At what point will both plans cost the same? So, let's go over this again. We have a fixed and variable rate, which I know you guys probably haven't talked about, but if you ever go into business, you'll get lots of things like this. First of all, we need to set up variables. We're going to say let C equal the cost of something. Let X be minute time, okay? So how many minutes, M-I-N-U-T-E, how many minutes a person spends on the phone? We're going to assume that this is a monthly plan, so we don't have to actually incorporate how many months they keep the plan for, okay? We just assume we're going to compare them per month. So, if that being the case, we know that, let's say, Bell, the cost of Bell was equal to $30 a month, so I had to pay $30. Whoa. 20? Sorry. Thank you. $20 a month, plus, depending on the amount of minutes, I had to pay 0.05 cents per minute, so times X. The Rogers plan was set up as the cost was equal to only per minute. So it was 0.15 X. There's no monthly charge. So there's no fixed cost. Okay? So you guys could have solved this using substitution, elimination, or graphing. I'm going to give you a little word of advice. If you get an option, graphing is usually the most difficult of them, okay? If it's your strongest, then go right ahead. But it can be very hard to anticipate where these two lines are going to cross each other. So it becomes very difficult to figure out how large I need to make the graph, okay? A very standard go-to one is substitution. So I'm going to solve this by substitution, okay, Michael? So kind of 2 at once here. So if we take a look, we have equation number 1, Bell, and equation 2, Rogers. I need to find their point of intersection. Okay? So what I'm going to do is I'm going to set an equation equal to a variable. I'm going to set equation 1 equal to a variable. What do I have to do that? Do I need to move anything around? Why not?
No, it's already C. It's already C.
It's already set equal to C. So what that means is C is equal to this value here. So I can take that value and plug it into the C in the other equation. Okay? So, equation 2, red, C equals 0.5. I'm going to plug in that amount for the C in the other equation, because we know C is equal to that. So, I get 20 plus 0.05x is equal to 0.15x. Okay? So the only variable now is x, and once I isolate to just one variable and some constant numbers, I can solve for it. So next thing I need to do is put all the variables on one side of the equation. I'm going to put my 0.05 to the right of the equation, so I'll be left with 20 is equal to 0.15x, subtract 0.05x. Once that's done, I'm going to collect my like terms, both of my x's. 20 is equal to 0.10x. Okay, so now that we've collected our like terms, I still need to isolate for my x by one variable. In order to do that, I need to move the 0.10 to the other side, or in other words, I need to divide both sides by this amount. Now, when I divide the left side by this amount, these two are just going to cancel out. So I'll just be left with x. And on the left side of the equation, we have 20 divided by 0.1, 200, right? Yeah. So 200. So I've discovered my x at 200 minutes, both plans will cost the same, okay? So I'm just going to put it in coordinate form just so we know. 200. I'd also like to know how much it's going to cost me, though. Maybe I don't want to invest any of this if it's going to be like $400 for 200 minutes, okay? So I'm going to plug in my x value into one of the equations. And in fact, I'm going to use the Roger equation just because looks like there's less to work with. So we take our Rogers equation, equation 2. C is equal to 0.15. And I'm going to plug in for x 200, because that will get me my cost. C is equal to 0.15 times 200. C equals 200 times 0.15, $30. So it turns out that if I spend 200 minutes a month on the phone, it's going to cost me $30, and it doesn't matter which plan I use, they'll both be the same. I'm going to extend this question. What if I spent less than 200 minutes on the phone? Which plan is better? Rogers is the better plan before.
Because you have that fee.
Okay? That fee keeps me over with Bell. Once we get over 30 minutes, Rogers becomes the more expensive. Or sorry, over 200 minutes, Rogers becomes the more expensive one.
Is that why I got one mark on this? Yeah, because that was kind of close.
Alright, we have two equations, and they've asked us to graph both of these equations to find the point of intersection, or in other words, to solve this linear system. Now remember, for us to graph, we set it up like y is equal to mx plus b. So what's important about this is all of our equations, when we go to graph, need to be set equal to y. Neither of the two equations they've given us are set equal to y. So we need to rearrange both of them. So let's take our first equation. 3y is equal to negative x plus 3. To set this equal to y, I need to, because this is multiplied, I need to divide all the terms by 3. Okay? So, when I divide the left side by 3, the 3's cancel out. I'm left with just y. Y is equal to negative x over 3, which can be rewritten as negative 1 over 3x, because there's always a 1 in front of the x, plus 1. So our first equation is set equal to y. Let's also do the second one. Our second equation reads 2x minus 6 minus y equals 0. The fastest way to set this equal to y will be to move the y to the other side of the equation. When I move the y, it becomes 0 plus y, which is just y. 2x minus 6 equals y. So finally, now that I have those, I need to just figure out what my slope is for both and my points of intersection. So for equation 1, my slope is what?
Negative 1 over 3.
Negative 1 over 3. And my y-intercept is? Good. Slope for the second question, 2 over 1. And our y-intercept? Good. So, we have our slopes and our y-intercepts. So let's do equation 1 first. It says our y-intercept is at positive 1. So I have my positive 1. And my slope is down 1, negative 1, and to the right 3. 1, 2, 3.
Are you doing the first one or second?
We're doing equation number 1. I wrote the wrong y-intercept. It's positive 1, which is here. We go down 1 and over 3. So we have our slope. Draw our line. We're all set up. Equation 2. Our y-intercept is -6. And our slope is up 2 to the right 1. So we go up 2 to the right 1. Up 2 to the right 1. And then we continue that pattern. So we start here. Continue the pattern. And we find that our point of intersection for this is x is 3 and y is 0. So, for our linear system, our answers are x equals 3, y equals 0, which we drew as a coordinate. Okay, question 2 from your quiz was an elimination question. So you needed to eliminate twice to solve for x and y. So what I'm going to do is I've decided I'm going to eliminate my x variable first. Right now they're all lined up together, x's above x's, y's and y's, and constants with each other. In order to eliminate the x's, I need the coefficients, the number in front of the variable, to be the exact same. So, to ensure that, I need a common multiple. And an easy way to do this is just multiply one equation by the opposite equation's coefficient. So, this question here, this entire equation, we're going to multiply by 5 because it's the opposite coefficient of this. So, I'm going to multiply this entire equation by 5. And vice versa. I'm going to multiply this entire equation by the opposite equation's coefficient, 4. So when we go to do that, equation 1 will become, remember we're multiplying everything by 5. (20x plus 15y is equal to 65. Okay? Equation 2 will become 20x minus 16y is equal to -28. Now, once that I've done that, my coefficients for the variable x are the exact same. I need to eliminate them. So what operation would I use to eliminate positive 20x? What is it, Michael? Good. We're going to subtract in this equation. When I subtract 20x minus 20x, we get not even x. What we really get, and I'll show you, is 0x, and what is 0 times x? 0. So it won't change anything, so we don't need to put it in. Now, this is where many of you guys made your mistake. Oops. The next part of the question says, positive 15 subtract negative 16. So in other words, that looks like this. 15 subtract negative 16. Which is also the same as writing 15 plus 16. 31y is what that equates to. Okay? And the other mistake many of you made, 65 subtract negative 28. That's the same as writing 65 plus 28. (65 plus 28 is equal to 93. So, I end up with 31y is equal to 93. And in order to isolate just y, I need to divide by 31. Y becomes 3. Which is great. I've solved for y, but I still need to eliminate to solve for the other variable. Remember, I told you I wanted you to use elimination twice. So let's rewrite those two equations. Now we have to solve for x. So our two equations were 4x plus 3y, 13. Is that right? And what was the other one? 5x. There we go. So there's equation 1 and equation 2 again. Once again, I need coefficients to be the same, I want to eliminate the y's this time. So I need our coefficients to be the same. So I'm going to multiply the first equation by the opposite equation's variable, which is 4. So I will multiply this by 4. And I'll multiply this equation by the opposite equation's coefficient, which is 3. So I multiply all of these by 4. And each term by 3 in the second one. And our two new equations read 16x plus 12y equals 52. And 15x minus 12y is equal to negative 21. Now our coefficients have the same unit value. They're both 12. But instead of subtracting to eliminate, what do I need to do to eliminate these two? I need to add them because one is positive and one is negative. Okay? So I'm going to be adding all of these terms. 16x plus 15y is 31x. Positive 12 minus 12 is 0. And 52 minus 21 plus negative 21, which is the same as 52 minus 21, is 31. I'll bring the 31x over. It's okay. And we end up with x being the value of 1. So our two values were x is 1 and y is 3 for our elimination. Number 4 from your homework last night said Riemann invests his summer's earnings of $3,050. He invests part of the money at 8% a year and the rest of the money at 7.5% a year. After 1 year, these investments earned $242 in simple interest. How much did he invest at each rate? So let's put our variables. We need to figure out how much he invested at 8% and how much he invested at 7.5. So we're going to say let x equal amount at 8%. Let y equal amount at 7.5%. I don't know why you would do that. Since we have those, we know that the total amount he invested was $3,050. And he invested a certain amount in 8%, which is our x. And he invested another certain amount at 7.5%. So our first equation reads $3,050 is equal to x plus y. Okay? We also know that after 1 year, the amount of interest he earned was $242. And the interest rates were 0.08 times the amount he invested in that, and 0.075 times the amount he invested at that rate. So our two equations read 3,050 is equal to x plus y. 242 is equal to 0.08x plus 0.075y. We have our two equations. Question 6 says, Jose wants to buy internet access. One service provider charges a flat rate, $34.95 a month. A second one charges $25 a month plus 33 cents an hour. What number of hours per month should Jose choose the flat rate? So this is very similar to our quiz question. We'll say let C be cost and let X be, what is it, per hour? Charges 25 plus 33 cents an hour. So it should be our hours. So amount of hours spent on the internet. So for our very first equation, we already know that our cost is equal to It's a flat rate of 34.95. Doesn't matter how many hours they spend, they're always going to be charged 34.95. So whether they spend no time or they never get off the internet, they still pay the same amount. The other company cost is equal to a $25 flat rate plus, depending on hours on the internet, 0.33 cents an hour, which is our X. So we set up the equation. It says to use substitution to solve this. Okay, question 15 deals with speed and time. You guys need to remember this. The distance of something is equal to the speed you're traveling at times how long you travel at that time. So we're going to set up our equations like this. I don't even know how to say that name. Benjix? Benji?
This is the worst names in the books.
Oh no, sorry, wrong question. A motorboat took 5 hours to travel a distance of 60 kilometers against the current. So, first of all, our distance is 60 kilometers. Our time was 5 hours. And they were traveling at a speed. Whoa. So where we were before, it took them 5 hours. And it says they went against the current. So whatever speed they were traveling at, we're going to call their speed, or we'll say average speed. Yeah, we'll call it S. So let average speed be S. And we'll say let current, the current of the water speed, be C. So because they're traveling against the current, it's their speed minus the current. The current would slow them down. On the way back, the question says the return trip took 3 hours. They were going with the current, so it's their speed plus the current, and they traveled 60 kilometers. So we have our two equations. Equation 1 and equation 2 for 15. You can choose any method you'd like to solve them.